Well, hello everybody. Welcome into Great Atmosphere. We got a lot to talk about, but before we get into it, I just want to give you a quick reminder to make sure to subscribe and hit the bell notification to make sure that whenever a new video comes out from the Great Atmosphere channel, that you immediately get a notification on whatever device you would prefer to watch videos on. So, getting into it, we're taking a look right now at our satellite view of the United States in general. We see that our main troublemaker that'll be coming into our area starting in early tomorrow morning is currently making its way going through the Central Plains and into the Mississippi River Valley. We talked yesterday quite a bit at length of where its current placement was. It was an upper level cutoff low at the time, centered over the Four Corners area, and you can see the static whites that you can see over the land, not the movement, the the specific white stuff that's on the ground. Of course, that is snow. So this has been quite the snowmaker for the Rockies as for the past couple of days, and now it's slowly making its way over into excuse me, the southeast U.S. No longer an upper level cutoff low, it's slowly transitioning into a trough, and as is the case with all troughs, as they come off of the Rocky Mountain plateaus in general, they will start to eject quite a bit of energy out into whatever is currently directly ahead of it, which for us is, well, it's the southeast. So it's been over 1,000 days since the majority, actually, not only the southeast, but the eastern seaboard has seen even an inch of snow. That is something that goes from the southeast U.S., from Atlanta all the way up to Boston, Massachusetts. Can you imagine that? Not having a winter without snow in Boston, New York, Philadelphia, D.C. It's been an interesting few years. Mainly attributed that to the mild and dry winters of the consistent La Nina southern oscillations of the El Nino southern oscillation that has been in place for the past few years. We, of course, have the opposite of that this year with a relatively strong El Nino in place that is currently reaching its peak. Most people mistakenly think that El Nino is most strong in the summer months because obviously it's heating up the eastern edge of the central Pacific. So you think, okay, well, what's the hottest time of the year? Summer? Well, I mean, that is the case, but unfortunately it'll stay warm throughout the course of the fall and the winter. And of course, when things are supposed to be cold in the winter and they're not, as is the case with the eastern Pacific at the moment, you get quite a bit of weather changes that would otherwise be different than normal. So that's what we're looking at here, and it'll be the first of many storms that probably make its way into the area going forward. We're going to move forward. This is what our water vapor looks like, just to kind of see where that moisture is coming from. You can see it's most predictably coming from the Gulf of Mexico, and the area getting quite a bit of strengthening. Or you can see the low center starting to circulate over into southeastern Kansas and northeastern Oklahoma, pulling in a lot of moisture from the Gulf, and we can see that this is referred to as a low-level jet. I believe we'll be getting to that in a second. Looking at what the Weather Prediction Center is currently looking at in terms of the next 12 hours, we see that there's quite a bit of mixed precipitation, rain, thunderstorms, and there's a few wind advisories that are out in the New Orleans area, southern Louisiana today, just because of that very thick moisture transport. You can see high pressure is slowly moving out of the area, and then we have our risk of freezing rain and snow for the Blue Ridge Mountains, Blue Ridge Escarpment, and the western North Carolina mountains for the next 12 to 24 hours. Looking at what the all hazards national map looks like from the National Weather Service, we see the blues over in our region. That denotes a winter weather advisory, which denotes a 50% chance of receiving either a tenth of an inch of ice or half an inch of snow within the next 24 hours. Winter storm warning is 1 degree higher than that. And then we see these browns. These are wind advisories. So we see this is very typical of the western Appalachians. We see that in far eastern Tennessee. And then we see as the system will move through into the Mississippi River Valley that the southern tier of New Orleans and Mississippi will be experiencing some high winds along with the Florida Panhandle and the Mobile Bay in Alabama. Taking a look at what that radar looks like now, you can see that it's quite a significant rain thunderstorm complex that's making its way through Louisiana and southern Arkansas. And most interestingly, we have a little bit of a cold tongue that's come down from the Canadian prairie that's actually eliciting a few snow showers going into the Ozarks and Missouri and central Kansas today. A little bit not expected. We weren't expecting moisture to make its way that far north, or the cold air to be making its way that far south. Excuse me one moment. So we're going to get into our first three elements that we normally look into when we are forecasting winter weather here in the Southeast. The first of which would be our moisture transport here in the 700 hectopascal or 700 millibar level of the atmosphere, pretty high up in the sky, but this is generally speaking where we would get our low-level jet, which is our primary moisture transport system that transports the necessary moisture we need in order to generate any kind of precipitation, whether that be rain, snow, or otherwise, into the southeast. So right now we see that beginning portion of the low center currently looking over central Oklahoma, and as low centers always circulate winds and everything anti or cyclonically, which would be counterclockwise, we see that we're starting to draw quite a bit of moisture at quite a significant pace up in from the Gulf and into Louisiana. And if you see the end result of this, you see that we are starting to make these lines come up and into the southern tier, the Ohio River Valley, Tennessee River Valley, and the southeast U.S. into the Carolinas. Moving into the next elements that we are always looking at, in addition to moisture, we need energy. We need strength of system, and the most efficient way that we usually denote that is by looking at the 500 millibar vorticity map. So in this particular map, we're looking for you can see these deep blues and greens. They are representations of energy. Now, when you have a high amount of vorticity in regions, you see specifically in regions that are exhibiting diffluent flow. So we see tightly pinched isobars right here that denote the trough for the low pressure, and then we see them quickly separate and they diverge in all these different directions. That is what we call diffluent flow or positive vorticity advection, and that emulates lift in the atmosphere. So anything that's in the atmosphere is going to rise when they have experience like positive vorticity advection. So we see that occurring here, moving through time. It might take a little bit to load, but we can see the overall. This is midnight going into Saturday, and we can see that it's actually deepened a little bit from what I have seen in the past here. So originally there was some short waves. So short waves would be like just little tiny delineations in a line, which don't look like much to most people, to a lay person, but they have significant impacts in terms of severe weather. In a highly unstable environment, whenever severe weather is coming down the pipe. This has a little bit more of a bend to it, which means that since yesterday when we looked at this, they might experience a little bit higher of a precipitation value, and that is probably going to be reflected in some of the precipitation model guidance that we'll see here in a few minutes. So we move through time, and it's out here pretty quickly. So you see. This is 6 p.m. on Saturday, and the majority of the vorticity has moved predictably up and into the northeast, and will soon be affecting primarily New England as we go into the overnight hours on Saturday night into Sunday morning. As we go forward in time, that's pretty much the end of the system. That's kind of the name of the game here, and why it's not going to be such a significant problem for us is effectively it's just going to move out very quickly. And once that happens, the clouds will open up. The sun should come out a little bit, and any ice that is on the ground should relatively melt rather quickly. So that's why you don't see a bunch of people ringing alarm bells and fire trucks going everywhere and salt on all the roads, or at least on all the back roads. It's because we don't expect this to be a primary major system, at least here in North Carolina, maybe not so in the western portions of Virginia. But we'll get to that in a moment. So as we look forward into what we're looking at timing-wise for this system in general. We have the GFS, the American flagship model, on the left, and we have the ECMWF Euro model on the right. These are the two major models that we always look at when it comes to forecasting, and we don't normally typically look at this when it's day of. We usually have better models for that, but it's always good to look on the flagship models because they give you a good baseline understanding of what to expect here. So we see that the GFS is a little bit stronger in terms of that vorticity gradient, so we're expecting a little bit stronger storms in Alabama, and not so in the European model guidance. But as we move forward in time, we see this is about 6 a.m. on Saturday, and this is when, and this moves in 6-hour increments. So it could be earlier in that 6-hour time frame, probably in that 3 to 4 o'clock a.m. Area. But we see that the freezing rain will start to begin in the northeastern parts of North Carolina. I would expect that it didn't really pick it up here. Well, actually, it did a little bit. So you can see at midnight coming into tonight, actually, on Friday, the far western portions of North Carolina, near I'd say Transylvania, Henderson County, Buncombe County, near Asheville, we'll probably start to see a little bit of the icy stuff start to occur with some light snow up in the Watauga County, like Boone, Blowing Rock, that region. We'll probably see a little bit of snow actually before most of the system starts to pull through. As we go through time here, the problem time will definitely be in that 6 a.m. to 12 noon portion of the day for Central Virginia. That's where we see the most significant values. GFS actually coming out predictably because of that increased vorticity gradient, expecting a little bit more energy with this storm, a little bit more convection. That one, you see the deeper blues and the whiter whites for depicting ice in this region, going up into Charlottesville, Harrisonburg, before we get into the DVA, going into forward to time. And as I said earlier, this is 6 p.m. on Saturday, and there's nothing there for the most part. Euro's a little bit slower. I would expect, actually, I think the GFS is wrong on this a little bit. The Euro does have a better indication that there will be some lingering fog, as is normally the case in freezing rain events. We expect a pretty thick nimbostratus layer of the cloud deck to be in place, and that'll gradually lower as temperatures decrease going into the night. So we do expect a little bit of fogginess and naturally a little bit a continuation of some potentially freezing fog. Not devastating freezing fog, mind you, but it'll still be something to keep an eye on going into there. And then by that time, that's when the full brunt of the nor'easter starts to occur. The low center will start moving off into that 40-70 latitude longitude range, which is the sweet spot for generating high snowfall. High snowfall amounts for the Northeast and New England. That's why you see such deep blues going on in the upstate of New York, Western Mass, and Vermont, New England in general. So moving on into what we are looking at in terms of timing-wise, we're going to look here at the NAM, the North American model. It doesn't go out as far as the global models of the GFS and the Euro, but it, generally speaking, does a better job at depicting precipitation and timing. So we're going to take a look at that. This is what the National Weather Service forecasters in Blacksburg and Greer, South Carolina, which are the two primary weather forecasting offices that are in place for this system. This is what they have been respecting the most. So we're going to go forward through time here. You see high pressure is currently in place, and as I was talking about yesterday a little bit, if we wanted this to be a major snow event, we would want this high pressure to be in place all the way up until the very end, because high pressure denotes sinking motion in the atmosphere, and as you know, the upper portions of the atmosphere are quite cold. So if the sinking cold air is coming down from the atmosphere under high pressure, that means that in place we have a lot of cold air already before the moisture comes in and before the energy comes in. That is the typical recipe for us getting a major snowstorm in the southeast. But you'll see that this high pressure system moves off the coast, or weakens quite considerably a little bit too quickly. And this is also a very important thing to keep in mind, is this 540 blue dashed line here. You see 546 is red and you see 540 is blue. The 540 millibar layer is denoted as, or is commonly referred to as, the rain snow line. So if you were at sea level and you were looking up in the sky, and you could see the 540 millibar layer was directly over you, you would expect any precipitation that would be otherwise on top of you to be coming down as a wintry mix, 50% of the time at least. However, that is at sea level. It is not denoting altitude. So you have to keep this in mind when you're looking at the 540 line. The higher the altitude you are, the further south you want to actually look at in terms of where you would expect snow and rain. And you'll see that here as we get into the next few lines here. So the 540 line at these higher altitudes are going to be quite significantly off, just because the mountains kind of do that. But you see the timing wise, we see this is 9Z. Actually, when did we first see it? So we first see this is 6Z. So this is about 1 a.m. We'll call it midnight tonight when we first start to see that freezing rain threat start to hit the Asheville area. We move forward in time, 9Z. This is since we're in standard time, that is at 4 a.m. This is when the majority. This is probably. I was mistaken when I said that the majority would probably be at 6 a.m. to noon tomorrow for the region. It'll most likely, according to the NAM, be a little bit earlier than that. We'll call it 3 a.m. Going into all the way. Looks like it's out of here by noon. So we'll extend the time a little bit. We'll say 3 a.m. to 4 a.m. all the way up to noon. To 1 p.m. tomorrow, and then this clears out pretty quickly. Like here in the Charlotte area, we're not going to be seeing much of the icy stuff at all, unfortunately for us. But the good news is that it'll be out of here by noon, and by out of here I mean probably we'll start experiencing some cloud breaks a little bit going into the afternoon, specifically the late afternoon hours going forward. And then moving forward here in time, we see that it starts to affect the northern portions of Virginia all the way going into the late afternoon and evening before it too starts to move out. And by 9 p.m., 10 p.m. on Saturday night, and this is tomorrow, the whole service area is pretty much is in the clear. So really quick, fast-moving system. Just going to be a flash of ice, it looks like, for the most part, is the main threat for those eastward-facing mountains. And we can see this depicted in the Blacksburg forecasting office's guidance. So this is the main communication forum that they have put out to the public and for news stations to use to their own benefit. Main thing we want to look at is impacts when we're 24 hours out. We have a general it's mainly we're looking at specific temperature profiles, hour by hour stuff, and just like little location types of forecasts. And also, but the main thing is making sure that everyone is aware and they know that all their emergency plans are in place before we move forward. So you can see that they have a very high likelihood of impact for minor impacts, few inconveniences of daily life, wintry driving conditions, which is probably the most important thing to keep an eye on, especially in the mountainous back roads of this region, and to just use caution while traveling. So pretty much it's going to come down to driving. And then on this map over here, this is a 20-30% chance of moderate impact. So these dark teals that you see, and we have a little specks of yellow in there depicting 40%, but primarily 20 to 30% chance, where you would see a little bit more of a disruption to everyday life, hazardous driving conditions, and some places will close. Like I am certain that the Blue Ridge Parkway has completely closed at this point due to this threat. Moving forward, just got to be really careful. And the dangerous thing about the Southeast, as most people know, is that it is very rare to get wintry events like this. So not a lot of people really know how to traverse them. So of course, not necessarily the main threat is the ice itself. Sometimes it's your neighbors and your friends who don't know how to traverse the ice going forward. So just be mindful of that as you move forward. This is what the Greer Forecasting Office is currently looking at here in South Carolina. The Greer, as we talked about yesterday, has been a little bit more bullish in terms of the amounts of ice that they expect with this. So you can see in their advisory area that they have, you can see McDowell County, Burke, Caldwell, Catawba, even Lincoln County, Iredell, reaching all the way over into, I believe that's Rowan County. You have a winter weather advisory area that can get from trace to 0.2 of an inch of ice. Now that's that's quite a big disparity in terms of the amount of ice, because a trace is a trace, but 0.1 of an inch of ice is 300 pounds of force on a power line. So we're looking at the difference between like nothing and 600 pounds of ice. So it's going to be very locally, it's going to be a very local forecast. So one area, let's say in Marion or Lenoir, is probably going to be very different than Hickory and Statesville and Lincolnton. And then we have our winter storm areas. Those are almost definitely going to get that 1/10 of an inch of ice, if not up to 3/10, which would be quite significant and quite crippling for a specific region of North Carolina that is quite difficult to traverse already by itself. Definitely does not need snow and sleet and ice to make it any worse for you. So definitely, if you're traveling in this area, travel in general, specifically along that I-26 corridor between Asheville and Tryon, is going to be, specifically Hendersonville right there, is going to be kind of under the gun in terms of major impacts going forward. What we looked at yesterday is also the SREF plumes. These are the short-range ensemble forecasting plumes. They do a pretty good job of depicting what kind of precipitation that we are going to experience on a location-by-location basis. So as you can see here on the chart, we're going to first look at our main area first in Roanoke, since that's the major metropolitan area that's under the gun for this particular system. The red line depicts probability of seeing a freezing rain, and then you see regular rain in the green, followed quickly after. Other ones that you'll see down here, blue would be snow and pink would be sleet. So here, and what we talked about also yesterday is that freezing rain is a self-limiting precipitation type, because if you look at it from a physical point of view, whenever ice is created, it is emitting heat away from wherever the ice is being generated, and thus that heat has to go somewhere. And thus the heat goes out into the atmosphere. Ultimately, if you do that on a large enough scale, it warms the immediate atmosphere, and thus, over time, melts the ice that it just created, unless that there is high pressure or dry cold air in place to constantly get rid of that excess heat that's been emitted and keep the ice in place. That is not the case, as we looked at, with that high pressure quickly moving off into towards the central Atlantic. So we can see quickly that as the ice forms, rain will follow. So this is that 12Z where we expect excuse me, an 82% chance of freezing rain, quite significantly high for a SREF plume model guidance for the Roanoke City area. Moving into Blacksburg, we could see that's pretty much at the same level. We'll move a little bit further south, and you can see that it's quite different. So anytime that the red line is above the green, that's when we would expect a freezing rain result. If it's green over red, then you can pretty much ignore anything underneath it. It's a probability. It's still possible. That's perfectly fine, but it is not expected. So as we go up into Surrey County, Stokes, Yadkin, we're seeing pretty much all rain here. We'll go into Boone and Blowing Rock region, freezing rain, quickly over into rain, with a little bit of backfilling snow at the end of that. That's quite interesting. I'm sure the ski resorts will appreciate that at Grandfather Mountain and whatnot. Going down a little further south, this is Hickory, as expected, mostly rain here, and that I-26 corridor in Hendersonville. Interesting that the probabilities are quite low for freezing rain here for the SREF plumes, but it's still higher than the rain, and then rain will quickly fill in afterwards. We'll look here in the Nantahala, pretty much too far south for rain, and then for fun, we'll look at Charlotte. It's pretty much completely all rain. So that's what we're looking at here from the SREF plumes model. Now, I'm going to look at something I didn't look at yesterday, which is kind of what the Northeast is going to be. It's a typical nor'easter. They're going to get some snow. And what I'm looking at right now is the Icon model, which is a new model, or newish model, that's based out of Germany. I've read a lot of research, actually, that the Icon has statistically done a very good job at reporting or predicting precipitation floors. So it not necessarily is good at predicting ceilings, which would be like the max amount that it could possibly get, but it's a great indicator in terms of how much like almost confirmed. It's not confirmed. I will never say confirmed. Sorry, but it's a good understanding of the floor of what to expect. So as we move forward in time here for the icon of the Northeast, you can see it building and building. These are very, very low point, maybe trace of an inch of snow in our area, but it will move forward. And you can see as that nor'easter begins to deepen, you can expect probably in the Boston Ranges right there is looking at 7 inches, and then Mount Washington in New Hampshire, Portland, Maine, looking at probably around that 7 to 8 inches range. Generally speaking, though, you can paint a broad stroke brush over the area, 4, 5, 6 inches, not entirely out of the question, and I would generally expect that if I were in that particular region. Just an interesting little tidbit I read through reading some research in about the icon. Quite interesting. We'll actually get back to that in a couple of minutes. Moving forward in time, though, so this, as I said, this ice storm, if you even want to call it that, will be very short-lived. It will not be a primary player in our weather pattern over in the next 30, even 36 hours after that. So that we do have multiple different things that are going to be in place coming up. And you can attribute it to many different things. The first one is primarily the El Nino peak. That is what most people will reference. You can also reference the polar vortex has weakened quite a bit due to a sudden stratospheric warming event that we've been witnessing over the past couple of weeks. But at first, I want to take a look at what the Euro has looked at for height anomalies. So this is what we're looking at: low and high pressures that it expects to be in place coming up. So we'll start in our current sequence. We'll move forward. I wish there was an easier way to move forward in the sequence, but we're going to move forward anyway. So we see this is our current system as it stands, moving into our region. Okay, so we'll get that. That's the short wave that we're going to experience tomorrow, and then we'll keep moving forward in time. So the main thing I want to point out to everyone here is when we're expecting a wintry storm, you see these straight lines that are coming straight from the Gulf of Mexico. You can expect that that's moisture transport coming straight into our area. So moisture is not the problem. Sometimes it is the problem when it comes, specifically last year in La Nina, we had almost no moisture transport. It was a very dry winter. It didn't even matter if there was very little rain as well. Not the case this year. We have from the warm eastern Pacific waters, we have a straight conveyor belt of moisture going over the Gulf of Mexico, getting enhanced even further and up and into the southeast and northern Florida region. So that is not the issue. What is the issue for us will be getting this cold and dry air and the energy necessary to create these storms to be able to precipitate. So as we move forward, we can see a little bit laggy. We can see that there's these little pockets of blue, and these are all future potential storm systems. Now, normally we would see these big high pressure ridges denoted by the reds to be mainly in place over British Columbia and the Newfoundland area over here in eastern Canada. And what those do is it develops a blocking pattern because it'll block some of these little elements of energy and moisture, or not moisture, just elements of energy and pathways for cold temperatures to come down from the Arctic from ever even having a chance of getting to us. That is not the case here. The main ridge, which represents the polar vortex, is actually centered over Scandinavia and north of Scotland and Iceland, with a little one that is formed over the western Arctic, but is not nearly as strong. So that leaves quite a bit of the Arctic air to be able to follow these little channels all the way down the Canadian prairie and into the United States. And since there is no major blocking pattern over British Columbia by any means, that means that anything that comes our way, essentially, from a North American continental perspective, is going to have very little in the way of it to be able to spark any kind of storm system. So we have the cold air, avenue here. We have the moisture transport, and we have nothing blocking the energy as it comes off the Pacific. So all of these things are quite interesting because they just haven't been in place the last couple of years, and all of a sudden, those things are in place, and we're experiencing what we're experiencing right now. So, and we can actually kind of see this as well. This is a representation of the 10 millibar view of the Arctic. And this is way up in the atmosphere. If you like, we're here on the surface, we're at about 1,000 millibars on average. This is 10 millibars, so this is pretty much stratospheric level, and this is where we would see the polar vortex. In a typical year, the polar vortex would literally just be a blue dot centered pretty much over the Arctic. Not the case here. This is an anomaly chart. So specifically over here, you see that this area of the stratosphere in the Arctic is quite warm compared to what it typically is. And this is called a sudden stratospheric warming event. First discovered, I believe, actually, in research done in 2018. I remember reading about it. Quite a bit of research has been done recently on it, and it is the polar vortex disruptor. And whenever the polar vortex gets disrupted, it has a means to transport in lower levels of the atmosphere colder air further south into more southern latitudes. And that is exactly what we're witnessing right now. As we see, we're looking forward in time. This is the day 10 to 15 temperature anomaly outlook from the Climate Prediction Center. And you can see here that they're expecting in the Central Plains and the Canadian Prairies to experiencing some high temperatures to be well below 18, maybe even 20 degrees, and this scale only goes to 20, so I expect these to be even more. We'll call it 25 degrees below normal for the area, and that's only going to stretch further down. So you can pretty much almost expect when it comes to like mid-January, we'll call it the 15th and 22nd weeks, it's going to be quite cold here in the U.S., and if we still have those energy pockets that are going to be making our way and the moisture transport's still there, it's pretty safe to say we're under the threat for a continued line of wintry threats as we move forward in time. And you can see kind of that's been reflected here with what they expect for the next system. We see much below temperatures in the U.S. hazards outlook, heavy snow here in Four Corners, and heavy precipitation. Before the cold air can get to us, though, we have our major player that will be coming forward in the next 4 or 5 days, mainly over Monday night into Tuesday. And this is generally speaking what is going to it's going to catch some people off guard. This is also looking at the icon again, the German model. And once again, this is a good representation of floors for precipitation. So this is representing all the way through into the end of the system that's moving into our area starting in tonight into tomorrow morning. Not much in the way of anything. You could call it maybe an inch in some places, probably a little bit less, half an inch generally speaking, over our area. This is for all accumulated precipitation, both frozen and otherwise. So we would expect in the Charlotte area and south and east to pretty much have like an inch, maybe, and probably a little less of rain. But then we move forward in time to our Monday and Tuesday outlook, and oh boy. Yes, that's a lot of rain. Specifically speaking, the ground temperatures are relatively cold, soil temperatures at least. They are quite saturated already, so they're cold and saturated, which means the ground is relatively impervious, and also it is to the extent that it is already quite saturated. There's not going to be a lot of places for these floodwaters to go, and that's going to be a major issue up in the Northeast as well. I think this is going to be our major player. The ice, I think, is kind of a red herring in terms of impact. This is going to catch some people off guard. Flooding next week is going to be the major story here in the Southeast, particularly you can see 7 to 8, 9 inches in that Henderson County, Transylvania County, Rawlings area. Fun fact about this particular area. This is actually considered, or it's like a few inches a year away from being considered a temperate rainforest biome. So it would be the only technical rainforest that we would see in the continent and the contiguous United States should this pattern of extended rainfall occur here in the far southern Appalachians of western North Carolina. So quite interesting, and you can see that reflected here. But it's quite a bit of rain. So we're going to take a little bit more of a closer look at that next week on Monday. But definitely keep that in mind as we move forward here in the next couple of days. And as is predicted, though, you can see the U.S. Monthly Drought Outlook. This comes out every other Thursday, and I believe the current one was released yesterday, if I remember correctly. Actually, no, it was last Thursday. Sorry, but the we are expecting whatever drought that we had here in the South and the Deep South to be pretty much eliminated by the time that system on Monday and Tuesday moves through. So that's a great thing. But we first have to get through the system itself and get through those flooding threats. So that's what I'm looking at here. Not to say too much, not much to write home about in terms of the ice storm itself. Doesn't mean to let your guard down if you're in any of those areas at all. But it's something to keep in mind going forward, that we do have multiple systems coming down the pipe, and it'll be quite interesting to look at here over the next couple of weeks. Once again, my name is Zach. I appreciate y'all tuning in to Great Atmosphere. I'll be back on hopefully Monday to be able to talk about whatever's going on here in the Southeast U.S. Please be sure to subscribe and leave a comment if you have any questions about anything in particular. I'd be happy to let you know my thoughts about it. So thank you again, and I'll see you next week. Bye-bye.